All right, so page 215, number 20, we are being asked to simplify this rational expression. And this rational expression looks pretty intimidating because it has an a and a b in it. It is a third-degree polynomial on top and a second-degree quadratic on the bottom. However, the process is all the same. We start by factoring the numerator and the denominator. The first thing we look to factor out of the numerator is a common factor. Well, you can see that the numerator has both terms have an a and both terms have a b in them. So we can factor out an a and a b. So let's do that. If we factor an ab out of ab cubed, the a is gone, and we've taken out one of the b's, so we're left with b squared. Minus, if we factor out an ab from this second term, then the ab comes out, and we're left with just a 9. And right away, I should recognize what I'm left with. A difference of two perfect squares. So this is going to be easy to factor again, but we're not going to do it yet because I want to take care of the first step in the denominator. All right, so let's factor out the common factor from the denominator. Well, let's look at the coefficients. 12, 12, and 144. 12 goes into all three of those. So we know we're going to be able to factor out a 12. So I'm going to put that out here. Then we have an A, an A, and an A. So we're going to be able to factor out the A also. So we're factoring out a 12A from the denominator. Well, if we take out a 12A from here, we're going to be left with b squared. If we take out a 12A from here, we're going to be left with a positive b. And if we take out a 12A from here, we're going to be left with a negative 12. And I like how this is unfolding because I noticed the difference of two squares on the top and the nice quadratic on the bottom. So I can now factor each of those. Remember that when we factor a difference of two squares, we take the square roots of each term with a plus and a minus sign. Now to factor the denominator, we have to go through our process. Set up my parentheses. Second sign is negative, so I automatically have a plus and a minus. Factors of b squared are b and b. And factors of 12 that will combine to give me a positive 1b as that middle term. Well, that's going to be a positive 4 and a negative 3. And of course, we should check our factors b plus 4 times b minus 3 by foiling to make sure that they multiply to give us that. And that check at this point should probably be able to just be a mental check. You shouldn't necessarily need to write that out. All right, so next, since the problem asked us what the domain is, we need to find the roots of the denominator. We need to find what values make that denominator 0. So I'm going to take, we have three things in the denominator being multiplied. 1, 2, 3. If any of those three things equals 0, then the whole denominator is 0. So I have to check all three of them. So I have 12a. When does that equal 0? Well, solve for a. If I divide both sides by 12, I'm still getting a equals 0. So that would make my denominator 0. So I know a cannot equal 0. Then I have b plus 4. When does that equal 0? Well, solve for b. Subtract the 4 to the other side. b cannot equal negative 4. Well, the third one, b minus 3. When does that equal 0? Solve for b. b equals positive 3. So I know b cannot equal positive 3. So in terms of answering the part of the question that asks me what is the domain, I know the domain can equal all the real numbers, but a cannot equal 0, and b cannot equal -4 or 3. Okay? Now we have to finish the problem of simplifying the expression. So we take what we have left right here, and we look for those common factors in the numerator and the denominator, and we cancel them out. So we see b minus 3 over b minus 3. Those cancel out. b plus 3 over b plus 4, those aren't the same, so they stay. I have an a and an a. Those cancel out. So what am I left with? b times b plus 3 on top, and 12 times b plus 4 on the bottom, and there's my domain. So this is the simplified version of the rational expression I started with, and that is my domain.